Assalamu alaikum everyone, I am Dr. Sadi, computer security researcher and malware reverse engineer. Today we are going to discuss about binary analysis and reverse engineering malware for beginners. As you know, this presentation is specifically designed for those people that interested in malware analysis and reverse engineering field, but they don't have any kind of background on it. This presentation also can be useful for those people that in intermediate level or advanced level on malware analysis and reverse engineering field. Finally, I hope you enjoy this presentation and learn something new with me. Let's start it. First of all, what's a reverse engineering? In a simple definition, reverse engineering or RE is the process of deconstructing software to understand this inner working logic and intent without access to the original source code. In addition, reverse engineering divided into two main parts. One of them is disassembling, that translating machine code to the assembly human readable, and also decompilation, reconstructing high level code. That means when you import the binary file into any kind of reverse engineering software like a binary ninja, Ghidra, IDA, Cutter, and so on, it will translating the machine code into the assembly. But the assembly language is not easy at all. Well, then decompilation came to play. This decompilation process is actually translating the assembly code into the high level code to C or the C++ that can be understandable more than assembly. And for the malware intent is determining if a file is a malicious. That is a main goal and the simple definition of reverse engineering, or we can say RE. The other primary goal for reverse engineering process is to extract indicator of compromise, IOCs, understand the attack vectors, and develop signature for detection and remediation actually. Well, when you perform the reverse engineering process through a specific software, as I mentioned earlier, like IDA, Ghidra, Binary Ninja, Cutter, Radar, and so on, you can actually extract the attack chain flow, attack vector, and any kind of the other information that can be useful for detection and remediation actually. So before deep dive into the other technical terms in a reverse engineering and malware analysis field, we have to know some types of malware in a malware landscape actually. We have many types of malware actually, like a worm, Trojan, Viper, Bunker, InfoStealer, ransomware, miner, rootkit, and bootkit. And each of them have their own capabilities, have their own functionalities, have their own stealthy mechanism, or they have own pilot harmony. The defenders, I mean. First of all, what's worm? Well, worm is a type of malware that self-spreading via a network share, like a WannaCry. That's a good example in our case. And nowadays, a modern ransomware also have a self-spreading mechanism. Could be via a USB drive, thumb drive, or network share. Also, the Trojan is a legitimate appearance and the payload hiding on it. So, in a simple term of Trojan, you have a legitimate software that a payload, a malicious software, bind it with it. So when you double click on it, the graphical user interface of this legitimate software pop up. But behind the scenes, in a background, not in a foreground, you are executing a malware also. That's a simple definition of Trojan 2. Well, the wiper, it's actually, we can say, a destructive malware. Because wiper have one goal, and the goal is destroying your system data, deleting your partition. It doesn't overwrite your MBR, it doesn't stealing your data, it doesn't make your computer slow, it doesn't performing crypto mining on your computer, it just delete your operating system from the root. About the bunker, well, the bunker is a type of malware that focus on a financial, stealing credit cards, stealing the payment information, and some people's abusing bunker malware to the carding operation. The info stealer actually is a type of malware that stealing wallet, password, cookies, and other sensitive information from your computer or from your enterprise network. Regarding to the ransomware, it's a type of malware that encrypting your operating system or encrypting your files such as a Word document, PDF file, your images, your videos, and ask for the ransom. Well, simply ask for money to give you a decryption key or the decryption software. Regarding to the miner is a type of malware that doesn't stealing user information, that doesn't wiping your operating system, that doesn't encrypting your data, stealing cookies, passwords, wallets, and so on. Even the miner is not abused for financial theft and fraud tools. Well, the one and main functionality of miner is steal CPU and GPU for cryptocurrency mining. Simply using your computer for the crypto mining purpose. Well, in a more advanced stage, we have rootkit. So the rootkit actually is a sophisticated one, more than Trojan, more than bunker, more than info stealer, even more than malware and Trojan. Because actually, the rootkit have a sophisticated, stealthy, and pilot armoring mechanism. The rootkit is able to hide their own processes from the e-process structure. That means you cannot looking for a suspicious process that related to this rootkit from the process hacker, from the process explorer, from the procmon, or any auto run. That's another process monitoring tools from the Sys Internal Suite by Microsoft Corporation. Rootkit is performing many kind of technique to stays as undetectable from your operating system for a long time. One of them is DCOM, direct kernel object manipulation technique. Also, the bootkit. It's a type of malware that infected master boot record, MBR, or VBR system boots. And we have two types of bootkit. Actually, one of them is MBR locker that playing like a ransomware ask for payment in order to providing decryption key. And in other side, we have a MBR malware that overrides your first 512 bytes on your sector 0 from your physical drive, and there are no other bootloader to make your operating system into operation again. So, the bootkit is also one of the sophisticated one, but don't abuse it regularly. And also, we have some kind of ransomware genre, some ransomware type that also override your MBR, master boot record. If you make it simplified for our audience, for our followers, for our students, when you turn on your computer, after a few seconds, the Windows logo, the Apple logo, gonna pop up on your screen. But when your computer gonna be infected with MBR, both locker and overwriter, you just look at on a MBR ransom node or the error message that tell you should again install the operating system from the scratch. Well, the goal of reverse engineering, or the goal of reverse engineering malware that related into our presentation agenda, is determine capabilities, what it does, and extract indicator of compromised IOCs to writing a signature and rules, and analyze the infrastructure like a command and control server who it talks to. Well, the reverse engineering allows security teams to build stronger defense by understanding exactly how an attacker bypasses current measures or bypassed current measure. Because actually, the threat actors always looking for a new technique, new method to bypass the security products. Well, before moving into the core structure of malware analysis and reverse engineering, you should build the isolated lab to analyze and investigate the malicious software, the malicious binary, the malicious file. In this case, there are three processes that we should follow as a security researcher and security analyst. One of them is virtual machine. Use VMware or VirtualBox because we should never run a malware on our host machine, in our real machine. In the virtual machine side, we are simply going to download the ISO image of Windows 10 or Windows 11 and use virtualization software like VMware, VirtualBox, Hyper-V, UTM, Parallel, and so on to install this virtual operation system. And after that, we have to take a snapshot on our lab because when we analyze some malwares, they are not only code analysis or static analysis or the basic binary or file triage. We may performing dynamic analysis, running actual malware in our virtual machine lab to see what functionality this sample are performing in a runtime. So when we have a snapshot, after writing reports, understanding the malware behaviors, writing a signature, and so on, we have to revert back to the clean state after every single analysis session. In a third stage, in a third process, we have to isolate our network because actually there are some malware types that have ability to escape from the VM machine into your host machine. Ensure the VM is on a host only network to prevent the malwares from coming home. Well, the analysis methodology of malware reverse engineering simply divided into main three part. Well, some of analysts says four, but the main ones is three. The first one is static analysis. Well, the static analysis basically is examination and investigation of the sample or binary file or software without execution, like a string analysis, import address table analysis, export analysis, PE header analysis, and so on. And in a dynamic analysis side, we are actually executing the malware itself in a real time from our sandbox. The last one is code analysis. That's where that's when reverse engineering comes to play. So code analysis is stepping through instruction with a debugger to find hidden logic. Well, actually, you can rely on debuggers for code analysis, or you can just use the reverse engineering utilities or reverse engineering instruments for the stage to understand the malwares widely, have a big picture. Because sometimes on with the static analysis or dynamic analysis, you may don't get a full picture, a full scenario. Well, the first stage, every analyst, every security researcher should follow is static triage or the file triage. Basically, it's a fingerprinting, okay? Like a metadata analysis and extension analysis, and so on. Well, in the fingerprinting, the attribution is for hashes, strings, imports, and exports. And the importance of hashes actually uniques identity of the file, because each file have their own unique ID. It's called hash, and we have a many type of hashes actually, like MD5, SHA-256, SHA-1. Well, the in a standard way, the security researcher mostly um, communicate with the SHA-256 because MD5 is vulnerable to hash collision. And hash collision is actually and basically the two files have a same hash or generate a same hash. And the examine tool for hashes is VirusTotal to search for any kind of malware samples or binary file that already uploaded into the VirusTotal utility. Well, the VirusTotal utility is an online tool used by SOC analyst, incident response team, malware analyst to run against multiple antivirus engines and sandboxes. And HashMyFile is a software or tools, you can say, for retrieving hash from the loaded binary and file into it. The second one, strings. Well, strings is a plain text, is a readable, human readable text found in the binary. And the example tools for string investigation and examination is strings from Sys Suite by Microsoft Corporation and Flosses by Mandiant. Well, strings cannot detect everything, but Flosses does. For example, when attacker hide their strings into the stack, strings are enabled to retrieving this data, but Flosses can. So in the strings you can find many critical information about the sample, URLs that related into the command and control server, IP, domain names, API names, registry key, file version, file paths, and so on. And for imports, libraries and API that program calls during the runtime to completing their own operation, there are many tools actually, like a PE Bear, PE Studio, CFF Explorer. And for export, it's actually a function provided by the DLL file dynamic link libraries. A good tool is PE Bear at all. Even you can use a CFF Explorer and PE Studio. So, PE section and the memory permissions. Well, the PE stands for portable executable. So it's a software that you are running on your operating systems. Okay, like a Google. It's a portable executable file. like a Microsoft Edge. It's a portable executable file. Okay, and inside the structure of portable executable file, there are something called PE section, and the section is divided into many parts: .text, .data, .resource, RCS, RCRC, and .bss, .rdata, .edata, and so on. Well, in the first section, .text, it's actually program code, and the correct permission for that is read and execute. And for the data that store a global variable and actually is a base of code and is a base of data, the permission is read and write. And for resource, that shortened with the RC and RC, it stores icons, dialogues, and images, and the permission is read only. Well, the threat actor sometimes is embed or simply put the payload into a resource section, and then using some of Windows APIs like a load resource, find resource, log resource to retrieving the executable file that hidden into the resource section during the runtime. Well, there are critical tips here. If a section is marked to read, write, execute, it's a massive red flag for a packer or injection. For example, as we have mentioned earlier, the .data permission is only read and write, no execute. But if you notice that .data permission is read, write, execute, RWX, it's a suspicious. Only .text section should be read and execute. Understanding packers. Well, a packer is a tool that compresses or encrypted or encrypts a binary to hide its true codes and string. Simply, in a normal or unpacked software, you will face a clean string is a clean software, a clean code. But when the malware sample or the software is packed, you may face the unreadable code patterns or unreadable strings. So the goal of packers is obfuscate strings and import address table. Well, I'm gonna discuss about some tips later about how you can spot the packers without any packer utility detection tool. And also, one of the primary goal of packer is reduce file size and bypasses signature-based AV. AV stands for antivirus product. So there are dozens of indicators that you can determine the sample is packet or not. One of them is high entropy. So the normal software entropy could be 4, could be 5, but in a packet sample, the entropy move into 7 and so on. And there are some tools that you can use for entropy calculation like detect it easy. Also, another indication for packet sample is few readable strings and non-standard section names. Well, there are other tips to detect that a malware is packet. Well, you have a sample, then import into a tool called PE Studio, move to import section or import address section, import address table section, sorry. You may face a few Windows APIs. Well, in a normal state, there are a dozen of Windows APIs. There are common free packers that developed by communities, like UPX, the most common open source packer. Use it for, for compressing and decompressing standard samples. And Empresses is a simple packer for executable file and DLL files, often used to reduce size without complex obfuscation. And we have an older packers called ASPack, but actually a persistence packer. A decryption stops follows a very predictable patterns in a memory. So packer divided into main three parts, such as compressor, encryptor, and protector. And each of them have different functionalities and capabilities. You have to know packing software or packing utilities, both free and commercial ones, is not for malicious purpose only. It mostly use it for protecting software against crackers, against those people that reverse engineering software to patching it and publish it online. Simply, it's called pirate software. And also, we have a commercial packer like a VM Protected, Thermida, and Ingema. Well, regarding to the VM Protected, it's a highly advanced visualized code into a custom bytecode that's extremely difficult to reverse. And Thermida is a specialized in anti-debugging and anti-VM technique to frustrate analysts. And Ingema adds multiple layers of protection, encryption, and anti-dumping measure. Well, as I mentioned it, both of structure and capabilities and functionalities of packers, both open source free ones that are developed by communities, and commercial packer can be misused also. For example, in a protecting software from the cracker side, the developers performing anti-debugging technique, anti-VM technique, anti-dumping measure, and visualize their code into a custom bytecode. So that also can be used by malware authors to protecting their malwares from reverse engineer and security analysts, and also to bypasses traditional or some kind of standard antivirus products. Well, there are some patterns to recognize obfuscation or encryption or packing. We are discussed about the packing a little bit ago. But regarding to obfuscation patterns, there are some basic stuffs here we can discuss about. It's not advanced, okay? Well, the first one is junk code. Well, junk code, some security analysts call it dead code, or some of them unusable code or unused code. So the junk code is meaningless instruction that do nothing. The attacker, the threat actors, or the cybercriminal groups just insert this dead code into their own malware sample just for frustrating security analysts. Because the threat actors know malware analysts processes or reverse engineering process is time consuming. When you work for a corporate network, enterprise company, organization, institution, universities, and so on, you have a limited time to understand the full functionality of this malware sample. That may you receive it from the phishing mail or drop it USB drive from the park, from the garage. Well, other pattern is spaghetti logic, is a excuse jumps and branches, and the last one is a base 64 or simple XOR on URL. A good example of dead code is instruction like a nope or add EAX 0 are inserted to break the visual flow of disassembler. Well, this junk code actually that affect visual graph flow from the reverse engineering instrument like IDA, like a Ghidra, like a binary ninja. But as security analyst, you have to know there are junk codes, encoded strings, and spaghetti logic that you can use for recognizing obfuscation patterns during reverse engineering processes. Well, regarding to recognizing encryption patterns, there are some indication that you can use. One of them is high entropy, data that looks pure random, noise, and tools, as I mentioned, like a detect easy, die, will show value near 8.0. And bytes loops, tight loops, processing data byte by byte, often using bitwise XOR. So when you import your binary into reverse engineering instrument, if you notice there are a lot of jumps, there are a lot of loops, that's one of the indication of um, encryption patterns or encryption mechanism on a this sample, but not in every case. And the last encryption pattern is fixed hex values. Example for IES appearing in the data section. I think for RC4 encryption mechanism, the hex value is 256. That's one of the patterns that you can notice that this sample is using RC4 mechanism as an encryption of the sample. Well, the malware is abusing Windows API, both standard and native. For example, for process manipulation, there are a lot of API names, like a virtual alloc EX. It's a modern version of virtual alloc that allocating memory in a remote process. That's why when you using a debugger like a XDBG or a DBG. For unpacking process, you have to use a virtual alloc and other APIs. And there are another's API called write process memory. It's mostly used for process injection that inject the malicious code into the another process. And the others API create remote thread that simply is executing code inside a legitimate process. Okay? An open process in a malicious context is gaining access to manipulate the system target. Well, we have to know that those API names and entire Windows API functionalities is not for malicious purpose, but it misused by threat actor to their own malicious intent. There are many others Windows APIs, but I have added this for one, like virtual alloc, write process memory, create remote thread, and open process. Well, there are others Windows APIs for data theft purpose that abused by info stealers and keyloggers, like set Windows hook EX that abuse it for intercepting keys and mouse. You can notice the set Windows hook EX from each type of keyloggers. And get asnic key state is actually pulling individual key status. Well, last but not least, HTTP open request is starting a connection to exfiltrate data. The other APIs is enum files and findneckers is abused for scanning for documents or crypto wallets. We have Windows APIs for many purposes: file enumeration, system enumeration, drive enumeration, and so on. Also, we have a Windows API that specifically designed for networking purpose, like connection APIs, Internet Connected, Win HTTP Connected, and W Startups are standard triggers for C2 communication. C2 is stand for Command and Control Server. That's a communication channels between the attacker itself and with infected machine. And exfiltration, you can watch for HTTP send request. Okay, that often carries the payload or stolen user conditional into the body. Well, when you notice HTTP open request is a standard for connection to exfiltrate data, but when you notice about the send request, it means the data has been sent or in process to sending into C2 channel. So the C2 channel can be Telegram bot, can be Discord bot, can be compromised domains, and could be a legitimate software. Because attacker also can abuse a legitimate software for C2 purpose. Persistence. Well, persistent mechanism is actually make the attackers to stays into your operating system after initial foothold or initial access. In a simple term, attackers drop a backdoor into a specific path from your operating systems that can be remains for a long time, for a short time, or for limited time. Even when you restart a computers, the malware start executing again. Well, attackers abuse local directories such as updata, the default hiding spot, hiding folders in the user profile, local temp, use it for dropping initial payload, often ignored by user, and startup folders, files here launch automatically every time you log in. Well, malware also hides in the standard paths to evade casual observation. Well, you can actually and simply detect it as suspicious samples and payload if you move into updata, local temp, or startup folders from your operating system's directories. The persistent mechanism also abuses startup folders, malware copied itself, or a shortcut.lng file into the start menu startup folders. And for the detection mechanism, a simple check of these folders reveal many low sophisticated or sophistication trojans and info stealer instantly. That's a folder pass from the um, left side. See users of data roaming Microsoft Windows startup menu program startup. Okay, I'm sorry, Windows start menu program startup. Or even you can right click on task manager. Oh, sorry, open task managers and move into startup label. And also, the attackers abuse registry run keys. Well, registry is a database of your operating system that store all of your activities and system activities. Open a file, open a document, and connected drive, connected thumb drive, connected printers, and so on. Well, the registry database is the most common persistent vector. If the program path is added as a value here from the current version run or current version run once, the malwares start when Windows start it boot. And it's very easy to detect it. You can just move into HK current user or HK local machine, software, Microsoft Windows current version run, or run once. Well, attackers abuse advanced registry persistent mechanism, for example, winlogger shell. Uh, this process is actually hijacking user init.exe or the shell key to maintain the persistence, or up init DLLs. Actually, this mechanism is forcing every process to load a malicious DLL. And last but not least, image file execution option IFEO is simply launching malwares instead of a legit program. Well, if you make it simplified this technique, basically when attackers perform this image file execution option technique in a notepad, when you click on the notepad, you actually executing the actual malware. And attacker um, get a persistence on your machine through service, creating a new system service via advanced IPI32. So advanced IPI32 also abused by attacker because it can work with the registry, system services, and so on. And persistent through schedule task. Well, what's a schedule task basically? Well, schedule task simply is putting your software or putting your specific information into the schedule time. Well, for example, you are scheduling your software to run at 1 p.m. every day, okay? Or every night, or every time. Well, malware uses the Windows task schedule. It's trusted utility by Windows operating systems to run at a specific times or even when the computer is idle. Well, advantage of malware author to abusing scheduled tasks is to maintain persistence on the infected machine after the first foothold, can run as a systems, avoid startup folder detection, can trigger a specific event is. Okay? And indicator of compromise. Well, what's the indicator of compromise in a simple term? Simply, we have a indicator of attack IOA and we have indicator of compromise IOCs. Indicator of attack, that's mean someone is trying to log in into your network through a brute force attack. Well, in the indicator of attack, your computer is not infected, but there are some indication that someone trying to log in into your server, into your exposed remote desktop protocol RDP from the internet. But the indicator of compromise, you're actually infected. That's why we are looking for the indication of compromise, like host IOCs, network IOCs, email IOCs. Well, IOCs basically stand for indicator of compromise. In a host IOCs or from the pyramid of pain, a host artifact is it contains file hashes, specific file names, registry values, and mutex, also strings. In a network IOCs, it's related to IP address of C2 server, domain names, and unique user agent string. Well, in an email IOCs, sender address, malicious subject patterns, and specific attachment names. Because actually, when you gonna be infected through phishing mail, the attacker drop a attachment or a malicious link for you. That's why we call email IOCs. The pyramid of pain, it's one of the essential terms and subject that every analyst should know it and have information about it in a simple terms. Well, the pyramid of pain divided into main 6 parts: hash values, IP address, domain names, network host artifacts, tools, and TTPs, technique, and procedure. Well, regarding to the hash value is one of the easiest to reveal the hash file on a specific file or binary file. Even you can use a normal utilities like a PowerShell by performing get hash file command, or you can use a normal software like a hashcalc, hash my file, or even you can use a PE Studio, PE Bear, and CFF Explorer or Detect Easy to reveal the actual hash file, MD5, SHA-1, SHA-256. And the IP address, it's actually is a simple to reveal. Sometimes you can just by investigate or examination the strings by using strings utilities from sysinternal, flosses, or bintext. And the domain name is the actual C2 server that malware authors communicating through it. And network host artifacts, IOCs, as we mentioned it, well, the hash values is a part of host artifacts, and IP address and domain names is a part of network artifacts, network IOCs. And the tools stand for this instrument that threat actors abuse it to their own cyber attack operation. like Injurat, Darkomen, Ardamax Keylogger, Cobalt Strike, Metasploit, Sliver, Adaptic C2, Havoc, and so on. And the TTPs is the hardest one to understand and to collect information and indication about it. Because in a hardest one, the TTPs, you have to reveal what technique and what tactic and what procedure that threat actor are abusing to get an initial foothold from the enterprise network or your machine. Well, nowadays, Pyramid of Pain is not useful at all. Maybe someone says, why? Well, let me explain for you. Regarding to the hashes, if the attacker just insert a null byte into the binary, the hash gonna change. If the attackers abusing fast flux technique into IP address, it will be defeated because IP address is gonna change every 5 seconds. And regarding to the domain names, attacker may be able to abuse domain generation algorithm mechanism DGA to generate hundred of domains in a runtime that may overwhelming or frustrated for security analysts to handle this. Because when you have a 100 domain, you may start thinking, okay, which one is a right C2 server? And regarding to the host artifacts or network artifacts, attackers simply can insert a fake user agent. Well, the tools, the attacker can change their instrument for cyber attack. In a last operation, mage attacker abused Enjurad, that remote access Trojan tool. But for the next operation, attackers or cyber criminal groups may use Cobalt Strike or Metasploit or Darkomen or Adamax Keylogger or Adaptic C2 or Havoc or Sliver and so on. And regarding to the TTPs, that's the hardest one from the Pyramid of the Pain, attackers may find a new technique or methods after weeks or years or months of researching. Well, regarding to network analysis beacons, well, beacons is a simply it's like a light that just checking, okay? Well, the C2 beacons, malwares contacted its server at regular intervals to check for a new command. This is called beaconing. It just checking for a new stops, for a new stop, for a new spots, for a new commands, and analyze checklist is their jitters, randomness timing, the traffic is encrypted, does the user agent match a real browser or the fake one? Because actually attacker can insert a fake user agent that look like a real browser. Well, you can actually simulating the network to reveal the actual command and control centers from the malware sample by using tools called FakeNetNG or Apache DNS or URL Monitor or URL Revealer by CahooSecurity.com tool. So fakenet ng is basically trick the malwares into thinking it has an internet connection. It can intercept HTTP, HTTPS, and DNS calls, allowing you to see the C2 URL without actually going online. And the safe traffic, as a tip for you, ensure that the malware doesn't actually exfiltrate your lab data or attack external target. Well, regarding to the debugging, well, what's the debugging actually? Well, debugging is actually put your software into the debug mode. You can play with the software in a running state. You can patch the software, you can change the instruction, you can view the stack, registers, return value, and so on. Well, debuggers divided into many parts actually, like runtimes, unlike disassembly. Debugging allows you to see variables and memory as they change, and pushing, you can push the malware just before it execute its malicious function. And the tools like x64 debuggy or debugger, that's a standard modern debugger for a 32 or 64-bit Windows application. Well, there are many debugger tools like OriDBG, uh, WinDebugger, WinDBG, or XDBG. So in a debugger, you have something called breakpoints and stepping. Well, breakpoint or BP, you just put a stop execution for the CPU. That's mean when you press F9 into one memory address from the X debugger, when a malware hits, it stop. And then you have a step into, you move into the deep of the function to see its code. But step overs run the whole function and stop at the next line. Okay? So actually, as a strategy, you can set a breakpoint on APIs like a write process memory. This stop malware exactly when it try to the inject code. Well, you can also put a breakpoint on a virtual alloc or virtual alloc EX for unpacking purpose. So regarding to the Windows internal, so Windows internal is a very important for security researcher and malware analyst. I always suggest to every newbie analyst or beginner analyst to learn about the Windows internal. Because actually, what the malware author is doing, abusing Windows internal utilities information to operating a sophisticated cyber attack against your company, against your enterprise network, against your infrastructure, against your institution or university. Well, what's the process actually? Process is a software, okay? And each process have their own components. Like a PID, it's a process identifier. Each process have their own unique ID. Even we have something called PID or PPID spoofing. And each process have their own handles, links to the file or sockets, and have their own permissions called security token, and have their own stack, heap, modules, and resources and virtual memory. Well, as we know, each process has its own virtual memory space. Malware must crosses this boundary to attack the others. So, as a recap and conclusion for that, a process is a software that run in a background and foreground, same as service, but service mostly in a background, not in foreground. Okay? When you double click on the Google Chrome, look at Task Manager, there are processes. So that's why I have simplified the process is a normal program or a normal software. And the thread. Well, actually, process without thread is not a process. Because process store the actual execution code. As explained from the slide, a thread is actual worker that execute code inside a process. That means the process without thread is not a process. And in a context side, the CPU state registers stack at any given moment. And malware also create remote thread to force its code into a alleged process. Okay, it's called remote thread injection. And modules. Well, modules actually DLL libraries that provide a functionality to a program, to a process, and simply malware loads WS2 32.dll, that's a low-level networking socket, or WinINET, Windows Internet.dll, high-level Internet HTTP, or advanced API 32.dll, that's accessing the registry. Well, as a note, if you see a DLL loaded from a temp, it almost certainty malicious. Even if you see that the sys file, the driver file or the executable files came from temp directory, it's almost certainty a malicious. Because if the program is legit, it have to their own directory from the C drive, maybe both program file for 64-bit or program file x86. It depends on the software architecture. Well, handles. So a handle is an abstract reference to a system resources like a files, key, and mutex. One of the most important tips here is about mutex. Well, you can actually detect the malware family through a mutex. So what's a mutex? Mutex is used to ensure only one copy of the file malware runs. So if you are already infected with the WannaCry ransomware, it creates a specific mutex. So when you double click on the WannaCry again, it doesn't infect your machine again because your machine are already infected and mutex are already presented from the WannaCry processes. And finding a unique mutex string is high. Finding unique mutex string is high fidelity indicator of compromised IOC. And also, mutex immunization. If you create a mutex with the same name as the malware will often think it's already running an exit, as I mentioned it earlier. Well, you can imagine like that. If the mutex already presented on your computer, on your infected machine, it doesn't infect you again because it's already presented. Well, regarding to the assembly fundamental, we have to know some instruction of assembly language to understand the wide picture during reverse engineering the sample or binary file through reverse engineering instrument. For example, we have move EAX EBX. Well, move actually copy a data from EBX to AEX. Well, the move instruction is right to left. For example, in this case, is copy data from the EBX register into the EAX register. And the push and pop is actually store and retrieve data from the stack. Okay, we have a stack, we have a heap, we have a stack frame. It's another topic. Maybe we will gonna create another presentation about it. And CMP and GNZ, well, CMP is actually comparison. It compare two values, two data. If the data is matched, it take a specific jump operation. So like a GNZ, jump if not zero, or GMP, unconditional jump. Okay? As I explain it from the slide, from the purpose side, compare and jump if not equal. And XOR EAX, a fastest way to say it, EX to a zero. Well, as a notice, when you see XOR operation or XOR instruction against same register, always the value is zero. Okay, like this, XOR EAX is a value always is zero or equal to zero. Well, actually, there are many anti-analysis techniques out of there, like a VM check. Well, what's the VM check basically? It check if the malware it's run inside a lab environment by looking for files, RAM CPU, MAC address. Okay? For example, a malwares have the anti-VM mechanism. It checks for drivers like a VB box for a virtual box software, or for VM tool sd.exe executable file, for VMware tool, and also looking for a small RAM, 2 GB or single core CPU. And regarding to the MAC address, it's starting with a 080027 for a virtual box. Well, sometimes the malware author is statically or hard-codedly put this value into the malware sample to checking for this artifacts, and if matched, it start killing itself. Well, process exit. Okay, that's mean when the malware notice it's not an actual host machine, it's a virtual machine, it's a sandbox, it doesn't run. It just kill and terminate itself directly. And there are others anti-analysis mechanism that malware uses. It's called debugger checks or anti-debugging. Well, one of the common ones is debugger present, a standard Windows API that return true if debugger attached. Okay? And the other one is RTTSC. Well, it measures CPU cycles. If a code runs too slowly because of the debugger, the malware exit. And last but not least, and the common one is INT3, int3, it scan memory for 0xcc value or to see if it's being watched. Last but not least, INT3 scan memory for 0xcc breakpoints to see if it's being watched. Well, regarding to the droppers, so a dropper is a file. Analyzing droppers, well, a dropper is the first stage. Its only job is to download the second stage, the real malware. And common API abuse it for droppers mechanism is URL down file, URL download file, internet open URL, and win execute. Also, if the malware is embedded into the resource section, you can looking for API like a load resource, find resource, and so on. So the resources related API. Well, the keylogger recognition, you can actually checking for set Windows hook ex API and get ASNIC key state and also log storage, because actually sometimes in a keylogger operation the attacker is create a directory or txt file or the config file or the unreadable pattern file from UpData that store your keystrokes and sent back into the command control center in a decrypted way. And also the ransomware logic. Well, the modern ransomware follows a disruptive patterns such as delayed shadow copies, backups via VSS admin, and also traverse all folders and encrypt data with a sometimes custom encryption mechanism, but mostly with the AES and RSA. Well, you can check from the strings to any commands like VSS admin, deload shadow, all copies, and so on. That's a massive indicator of ransomware operation or ransomware malware sample. Well, for practical unpacking UPX, you can just follow this workflow, like identify UPX 0 and UPX 1 section. So simply, sometimes you can just identify the packing from the section names, because when you packing the malware or compressing the sample with the UPX, ASPAC, and Empress, it create their own section from the section table like UPX0 and UPX1 and Empresses and so on. Then you can find the tail jam at the end of the unpacking stop. Then you can dump the memory just after the jump to the real entry point, and you can use Scala for fix the import address table IT. Well, regarding to the analysis workflow checklist, you can generate file hashes, search virus total, check section for RDWX or high entropy, run in an isolated lab with a Prockman or Wireshark, identify persistence or registry startup, extract the C2 infrastructure IP URLs, and document unique mutex and string. Well, there are some common mistakes that analysts doing. Well, one of them is over reverse, like spending 4 hours on an assembly when 10 minutes of dynamic analysis show the URL. And the second mistake is dirty lab, detonating a second sample without reversing the first one's snapshot. Sorry, the second one, dirty lab, detonating the second one, dirty lab, detonating a second sample without reverting the first one's snapshot. And the last one is host leak, analyzing malware with the shared folders or internet enabled on the VM. Well, always stay curious. The best way to learn is by doing. Download sample from the malware bazaar and start reversing safely. You can use tools like Ghidra, X64DBG, Flare VM, or and run online sandboxes. Thank you.